Okay, today we'll do the higher derivatives. Okay. Last time we did differentiation, like the derivative, we're just doing the first derivative, right? And today we'll be doing the higher derivative, which is just the collective of the first, second derivative, third derivative, fourth derivative, etc. So from the second derivative until the nth derivative, these are called the higher derivative. So the higher derivatives, in other words, it refers to taking the derivative of a derivative, right? Because to get the second derivative, we have to differentiate the first derivative. To get the third derivative, you differentiate the second derivative, then and so on. Right, and another thing, high order derivatives. Okay, the reason we need to learn the high order derivative is because it can capture information about other functions while the first order derivative cannot capture. So can be more, can be, if they are more advanced, then yes. Okay, we have the notation. Oh, let's get to the notation for those derivatives. Suppose we have f at x, and okay, this is the function that will differentiate. Okay, for first order derivative, you'll use this notation. You'll use f dx, meaning we are differentiating a function f with respect to x, right? Or we can write this as an f prime at x, right? That's what you use to represent the first order derivative, like meaning we are differentiating a function once, right? And I said we have the second, the third, the fourth, and so on. Okay, for the second derivative, you will use it differentiates the derivative, the first derivative, and this gives you d squared f with respect to x, right? Remember, I said to get the second derivative, okay, first, to get the first derivative, you differentiate the function f, right? Then to get the second derivative, you differentiate the first derivative. That's why we have df with df of dx with respect to x, meaning we are differentiating the first derivative with respect to x, and that gives you d squared f with over dx squared. This means we are differentiating f twice, or it means we are differentiating the derivative of f. Or again, you can just write f prime prime at x, right? If you see 1 prime, meaning we are differentiating once. If you see 2 primes, that means we are differentiating twice, okay? Then we have the third derivative. The third derivative. Here, we are differentiating the second derivative, right? So you can represent the third derivative as in d of the derivative of the second derivative. Remember, this is the second derivative, so we're differentiating the second derivative. And this is the same as d cubed f with respect to x, meaning we are differentiating f 3 times. And you can write this as an f 1, 2, 3 at x. Okay. For a fourth derivative, here we are differentiating f 4 times, meaning we have the derivative. We are differentiating the derivative of, we are differentiating the third derivative, or, and this gives you d4 f dx squared. We are differentiating the third derivative, or we are differentiating f 4 times, and this is the same thing as f of x, right? Up to the nth derivative. You can write the nth derivative as dn f with respect to x, meaning we are differentiating f n times, right? And this is the same, you can write this as in fn of x. Okay, let's do examples. Before we do examples, do we have questions?
Hello, Miss Kwam.
Yes, hi.
How are you?
Okay.
I want to know that do you know about another DSC 1502 class that is started today from 5 to 8? They said they are coming from UNISA.
Maybe there are the tutors. I don't know what they are called, but yeah, it's just extra. It's extra help.
Oh, okay, thank you.
Okay, let's do examples here. Okay, we are still applying the same rules, the ones we learned, I think Monday. Yeah, the same rules still applies here. Okay, for example, suppose we are given a function c at x equals x to the power 5 over 5 minus 2x to the power 4 plus 5 over 2 x cubed minus 8x squared plus 100x plus 150. Suppose we are asked to find the first, second, and the third derivative for this function. Meaning we are asked to find c prime, c prime prime, and c triple prime. Okay, remember I said we will use the same rules, the ones that we learned, rules of derivatives. Okay, if you look at this function, our c, right? You see, we are given a polynomial function here, right? And if you are differentiating a polynomial, that means you have to use a power rule, right? And remember, the power rule says if f at x is equal to a x to the power n, right? Then f prime at x would be a n x to the power n minus 1, right? And another thing, if f at x is equal to a constant, let's say our constant is a, right? And you are asked to differentiate this function. F at a is a constant. F at x is equal to a, and a is a constant. Remember, the derivative of a constant is 0. Right? So we have f prime at x equals 0. Right? That's the rule we'll use here. Okay, let me take this. Okay, here we have c at x equals x to the power of 5 over 5 minus 8x cubed plus 15 over 2. Oh, ish. Cx is equal to x5 over 5 minus 2x to the power 4 plus 5 over 2 x cubed minus 8x squared plus 100x plus 150, right? And then another thing, if f at x is equal to f1 plus f2, then the derivative of f prime will equal to the sum of the derivative of f1 and f2, meaning f prime at x is equal to f prime 1 plus f prime 2, right? Okay, and then we can do the derivative of this term separately, as in we can say c prime at x is equal to the derivative with respect to x of x to the power 5 over 5 minus 2, the derivative of x to the power 4 with respect to x, plus 5 over 2. Even here, you can take out this 1 over 5. Okay, 5 over 2, the derivative of x to the power 3 with respect to x, minus 8, the derivative of x squared with respect to x, plus 100, the derivative of x with respect to x, plus the derivative of 150 with respect to x. Okay, remember we're going to apply this rule, right? Because we said we'll apply power rule here, since this is polynomial function. Okay, if we apply this rule here, okay, here we have 1 over 5 times the derivative of x to the power 5. Okay, you take 5 down, you multiply with it, then you minus 1 from 5. So we have 5 minus 1, which is just 4, right? Again, you have minus 2 times, you take 4 down, you subtract 1 from 4. Then that's the new power, right? Plus 5 over 2. You take 3 down, then you subtract 1 there. You'll be left with 2. Minus 8 times 2 times x. From 2, you minus 1, so you'll be left with 1, right? Plus 100, the derivative of x is 1. So we have 100. The derivative of a constant, which is 150, the derivative of 150 is 0, right? So I can just write plus 0. And then the next step is to simplify this, multiply out the brackets. We have 5 over 5, that's 1. So this means here we'll be left with x to the power 4. We have minus 2 times 4, that's minus 8, x to the power 3. Then we have 15 over 2, x squared. We have minus 16x plus 100. Okay, this is our C prime. Remember, we are asked to find C prime prime, and we said C prime prime, the second derivative, we'll get the second derivative by differentiating the first derivative, right? So you can write C prime prime as the derivative of C prime with respect to x, right? And we know C prime is this, so this means we can write the C prime prime as the derivative of this function, x to the power 4 minus 8x cubed plus 15 over 2 x squared minus 16x plus 100. And remember, we said we can separate a function like this and differentiate each term, and then we add them. Okay, meaning we can write C prime prime as in the derivative of x to the power 4 with respect to x minus 8 times the derivative of x cubed with respect to x plus 15 over 2 times the derivative of x squared with respect to x minus 16, the derivative of x with respect to x plus 100, the derivative of 1 with respect to x, right? Then we can do our differentiation. Derivative the derivative of x to the power 4, again, we're still using the power rule. The derivative of x to the power 4 will give us 4x cubed. Then the derivative of this will give us 8 times 3. Take 3 down, then we subtract 2 here. Again, here, you take 2 down, you subtract 1 there from 2. And the derivative of x with respect to x is 1. So we have minus 16 times 1. The derivative of 1 or the derivative of 100, it's 0. So we have plus 0. Then you simplify. This will give you 4x cubed minus 24 minus 24x squared plus 15x minus 16. And this is your second derivative, like your x, you see prime prime. We also find the third derivative. We said to get the third derivative, we have to differentiate the second derivative, right? So this means prime prime is equal to the derivative of C prime prime with respect to x. And this is E with respect to x of 4x cubed minus 24x plus 15x minus 16, right? Again, you can still separate these and write them as 4, the derivative of x cubed with respect to x, minus 24, the derivative of x, here it's squared, x squared, the derivative with respect to x, plus 15, the derivative of x with respect to x, minus 16, the derivative of 1 with respect to x. right? Okay, if you differentiate here, you will have 4 times 3 x squared minus 24 times 2 x plus 15 times 1. Here it's 0, right? Because the derivative of constant is 0. And then you simplify this, you get 12 x squared minus 48 x plus 15. This is the third derivative. Suppose we are asked to find the fourth derivative. Remember we said to get the fourth derivative, you need to differentiate. You need to differentiate the third derivative. So you can write this as in the derivative of the third derivative with respect to x, and this is derivative of x, the derivative of 12 x squared minus 48x plus 15, right? Okay, and this, okay, you can still separate this and write it as a derivative of x squared with respect to x minus 48, the derivative of x with respect to x, plus 15, the derivative of 1 with respect to x. Okay, differentiate from here, you'll have 12 times 2x, because you subtract 1, minus 48 times 1, because the derivative of x is 1, plus 15 times 0, because the derivative of 1 is 0. Okay, and we simplify, you get 24x minus 48, right? This is the fourth derivative. Suppose you were asked to find the fifth derivative, which is the derivative of the fourth derivative. And you can write this the same way, the derivative of 24x minus 48 with respect to x. Again, you can separate this and differentiate separately. If you do that, you'll have the derivative, or you'll have 24, the derivative of x with respect to x, minus 48, the derivative of 1 with respect to x, right? So here, okay, you have 24 times the derivative of x, which is 1, minus 48 times the derivative of 1, which is 0. So this means you have 24. This is the fifth derivative, right? Suppose you were asked to find the sixth derivative again, right? Which is the derivative of the fifth derivative. And this is the same thing. Oh, we just got this is not here. Okay, which is the same thing as the derivative of 24 with respect to x. And then 24 is a constant, right? And the derivative of a constant is 0. So this means if you are given that function and we are asked to find the sixth derivative, you'll get 0. Okay, that's how you will differentiate. Okay, we're just going back to the rules that we did last time, and we use them, we apply them. Okay, do we have questions before we move on? Yes, no? Okay, this is the part where you have to unmute your mic and then you talk.
Hi, sorry, ma'am.
Yes.
Can you please go back to your screen and go a bit up? Like I couldn't finish making the notes.
But you're still going to get the thing in the recordings when it comes to notes taking. Where should I go? Is there a breaking today? Yeah, go ahead. I'll assume you guys you do understand since you're not saying anything, you're not asking questions. So that means I don't even have to do other examples. I can just move on to the next section. I don't know.
Hi, ma'am. Can you perhaps maybe do an example that involves having square roots and fractions?
Okay. Suppose we are given our f of x as in root x e to the power x, right? Okay. Let's say we are asked to find f prime, f prime prime, f like the first derivative until the third derivative. Okay. We said if we have a function like this, a product of two functions, we have to use a product rule if we're differentiating a product of two functions, right? Like, and the product rule says if f at x is given as u at x times v at x, then the derivative of f with respect to x will be you differentiate the first function, which is u, you keep the second function as it is, then plus you keep the first function, you differentiate the first function, the second function. Okay, this is the rule that we use here. Suppose we'll let our u at x to be square root of x. Remember, you can write the square root of x as in x to the power a half, right? And then we let our v at x, the second function, to be ex, right? For us to use, to apply this rule, the product rule, we need u prime v, u v prime. But for now, we only have u and v, but we can find our u prime and v prime from u and v, right? Okay. You see, our u is x to the power a half. So find u prime, we need to apply the power rule here. And if we apply the power rule, 2x to the power half, u prime would be 1 over 2 x to the power minus 1 over 2, right? And you can write this as 1 over 2 root x, right? Okay. And our v is e to the power x. We use the law of exponent. The exponential, that law, exponential rule of derivative. And it says if we are differentiating e to the power x, the derivative of e to the power x is the same as that function, which is e to the power x. So this means our v prime would be e to the power x, right? And we can now take our u, v, and u prime, v prime, and substitute them back here. So this means our f prime at x, which is u prime, okay, our u prime is 1 over 2 root x, right? U prime is times e to the power x, right? Plus we have our v, our u is x to the power 1 over 2, right? And our v prime is e to the power x. You can, you can leave it here, right? Because we still want to find x, f prime prime and the third derivative. But if you were asked to find only the first derivative, then from here you could have left your answer as in 1 over 2 root x plus root x. You should have left your answer like this. But since we are still differentiating, right? But even here, even if you leave your answer like this, you can still
Miss Como, we can't hear you anymore. You're a Congo. Congo.
F1 with respect. Is it you or every? Yes, guys.
Everyone.
Hi.
Yes, hi.
Oh.
Can you? Yeah. Okay, guys, this is the part where you have to unmute your mic and say yes if you can hear me, no if you can't hear me.
No,
Yeah,
we
we
can
can
hear
hear
you.
you.
We can't hear you, ma'am.
And then all of you.
Only now
Yes,
can we
all
hear
of
you.
us.
Only now we can hear you.
Suppose.
Like for the
Couldn't
past,
hear you while you
like
were doing
2 minutes.
those.
Yes, yes, we cannot hear you, ma'am.
Where did I lose you all?
No, we're here now.
You were about to move to the second derivative of that question.
Oh, okay. Thank you. I said to find the second derivative, you have to differentiate the first derivative, right? Okay. And our first derivative, we said it's e to the power x times 1 over 2 root x plus root x, right? So it means we are differentiating e to the power x times 1 over 2 root x plus root x with respect to x. Again, here you
Sorry,
see.
ma'am. We can't see where you are writing.
Okay, I'll stop sharing. Then I'll share again. Can you see my screen now?
Yeah.
No.
Yes.
All right, thank you. Okay, I said if you look at this function, again, here we have a product of two functions. We have this function times this function, right? So it means we can let the first function to be u, and u is e to the power x, right?
Yes,
And the
Tomo,
second function, yes,
we still don't see where you are writing.
all of you.
No,
No, that's
ma'am.
Yes, your screen is stuck on the same. The screen is stuck on the same answer of the first derivative. So as
Yeah,
you're
the screen
explaining,
is
This
not
is
small.
correct, we can't see. But we
in here, use just your screen that we can't see.
I guess that the network issue I'll never win because I changed it last time. Okay, let me unshare and share again. And stop sharing. And guess. Can you see my screen now?
Yes, ma'am, we can. Yeah, but
Yes.
it's the
Yes.
same
Okay.
screen.
Yes, ma'am.
Right. I was saying now we want to find the second derivative by differentiating the first derivative. The first derivative is e to the power x into 1 over 2 root x plus root x, right? And you see, this is the product of two functions, meaning we have to use a product rule here to find the second derivative. Okay, again, I let the first function to be u, and then the second function to be v. Okay, and this is 1 over 2 x to the power minus half plus x to the power a half, right? This is the same thing, this and this, right? And we remember to use the product rule, we need u, v, u prime, v prime, right? For now, we have u and v, but we can we can differentiate u to get u prime. Okay, we have u prime, okay, u is e to the power x. If we differentiate e to the power x, that function, the derivative of that function is itself, right? Here we have 1 over 2 x to the power minus half x to the power half, right? Meaning we have a polynomial. To differentiate a polynomial, you need to use a power rule, right? And if we use the power rule here, we'll have minus 1 over 4 x to the power minus 3 over 2 plus 1 over 2 x to the power minus 1 over 2, right? Okay. And then I said if f prime is this, and we want to find the second derivative, and we let this to be u and this to be v, then f prime prime, since we are using the product rule, will equals to u prime v plus u prime v plus u v prime. Okay, now we can substitute our uv back. Okay, our u prime is e to the power x, and our v is, okay, I'll write this as 1 over 2 x to the power a half plus x to the power a half, right? Plus our u is e to the power x, right? And our v prime is minus 1 over 4 x to the power 3 over 2 plus plus 1 over 2 x to the power a half, right? And then if you were asked to find just the second derivative, that means you need to simplify this further, and you can write this as e to the power x into 1 over 2 root x plus root x plus e to the power x into, was this minus 1 over 4 square root of x cubed plus 1 over 2 root x. So you can't leave your function like this if f prime prime was the final answer. You see, you still have the common factor, which is e to the power x, and if you take out e to the power x, you will get 1 over 2 root x plus root x minus 1 over 4 root x cubed plus 1 over 2 root x, right? Now we have 1 over root 2, 1 over 2 root 2 and 1 over 2 root 2. We can add these two, and if we add these two, you will have, they will give you 1 over root x, because it's like half root x and half root x, right? That means you have the whole root x. Okay, then this is 1 over root x plus root x minus 1 over 4 root x cubed. Right, this will be your final answer. Okay, again, to get the third derivative, you do the same thing. We are differentiating a product of two functions. You take this to be u, you take this to be v. You find u prime, you find v prime, and then you substitute them back on your product rule. Do we have any more questions?
Hello, this root x stuff is slightly confusing. Could you please start again? The root the root x3 was what I find confusing. I was under the impression that that would be maybe 1/6 because of the polynomial thing. So I would appreciate if you could try do that with maybe a slightly more complex power within the root, so that we can actually make sure that we understand what's going on with the roots and polynomials there, please. Thank you.
Which root? You mean root x cubed?
Yes, root x cubed. I was under the impression that when you find the derivative of that, it would maybe become 1/6 or something. So I'm just trying to understand what's going on. So if you could start a similar polynomial like that from the beginning, maybe I would understand why it's not.
You mean if you, okay. Where did I differentiate? You mean I should differentiate x to the power 3/2? Or I should show you how did I write x to the power 3/2 as in 1/square root of x cubed?
Yes. So maybe I'm confused that maybe that the cubed becomes basically on top of the two. Yeah. I think I'm-
On our last section, last class, I said if you have x to the power 1, okay, mn, right? Then this is the same. You can write this as in the m root of x to the power n, right? So here we have, okay, let's say we have 1 over 1/2. 1/2 is the same thing as the square root of x to the power 1, right? Because now our n is 1, right? Using this rule, and our m is 2. Remember, if it's the square root, you don't have to write 2 here, right? And if we had x to the power, maybe, let me just say 3/2, right? This is the same thing as x to the power 3, okay, the square root of x cubed, right? And if we had x to the power now 2/3, then this is the same thing as x to the x squared, the cube root of x squared, right? And if we have x to the power maybe 4/3, this is the same thing as x to the power 4, like the cube root of x to the power 4. And if this was 3/4, then this is the same thing as x to the power 3, the fourth root of x to the power of x cubed. You remember that this is what we did last time on our last class, I think Monday.
Sorry, ma'am, can I ask a question?
Oh,
I just want to find out.
I'm listening.
Sorry, ma'am, I just want to find out, when you took out e to the power x as a common factor, how did you do that? Because I saw a plus sign over there. Are we allowed to do that?
Yeah. Okay, this is the same thing as EA, e to the power x plus a to the power b.
No, when you in the question when you took it out, the e to the power x as a common factor, if you could go back to it,
yeah,
I don't understand how you did that.
This is where I took out e to the power x. We have e to the power x times this bracket, and you have e to the power x times this bracket. Okay, I will take this bracket as a and this bracket as b, right? Meaning we have e to the power x a plus e to the power x b. You can write this as in e to the power x. You take out e to the power x here, you'll be left with a plus. You take out e to the power x here, you'll be left with b. So you can write this as in like this, right? We have e to the power x that bracket with plus we have e to the power x that bracket. Okay, let me go back there. We have e to the power x this bracket plus e to the power x this bracket. Meaning e to the power x is the common factor of these two terms.
Okay, but I was under the impression that because there's a plus sign in the middle, there's an operator sign, that we couldn't take out a common factor.
That's where you take out a common factor if they are operation like that. If we had minus, we could have taken the common factor again, which is e to the power x. Maybe.
Okay, thank you.
Okay. If this bracket wasn't here, maybe if we had something like if e to the power x times this plus root this plus e to the power x times this until here, then plus here. There we wouldn't have taken a e to the power x as a common factor, because that e to the power x, we don't have e to the power x here and here. We only have e to the power x here and here, since we remove the brackets. But since we have a bracket like this, it means e to the power x goes with everything in here in this bracket, and again it multiplies everything here. Do we have any more questions?
I have a question here.
Yes.
Hello.
Yes, I'm listening.
My question is, I would say it's based. Yes, my question is based on the power, the rules of adding the roots, because I'm trying to roots, basically the rules of adding roots, because I'm failing to understand how 1/2 root x plus 1/2 root x just became 1/root x.
X of x, right? You mean this?
Yes, ma'am.
Yes.
This is the same thing as 1
Yes,
over
that
2
one.
x to the power minus 1/2 plus 1/2 x to the power minus 1/2, right? These two terms, they are the same, meaning we can add them. It's like
Okay.
half x plus half x. Half x plus half x is 1x, right? Okay, it's the same thing as 1/2a plus 1/2.
Oh, okay, now I get it.
A.
All right.
Yeah, that's why we have just a, which is
Thank
1/x. Okay. Please guys,
Okay,
giving
yes,
you 5 minutes, please.
Okay, so basically,
Okay, I'm giving you 5 minutes to find f prime and f prime here. This is our function. 5 minutes starting from now. Okay, it's 7. We'll do it together at 7:05. Please attend it for now. Comment. Just the first derivative and the second derivative.
Are you guys done or you need more time? What did you guys get as your first derivative?
E to the power of x multiplied by nx
Multiply by?
x multiplied by x to the power of 2
Okay.
plus ex multiplied by 2 over x squared.
So the final answer is e to the power x into ln x squared plus 2 over x.
The what? The final
The
answer.
answer is
You mean
e
the
to the
second
power
derivative
x,
of the first derivative?
the first derivative,
Okay, it's e to the power x.
into ln x squared plus 2 over x.
Correct.
Did you all get this one? Anyone with a different answer? Okay, there's no wrong or wrong, right or wrong answer. We all here to learn. Anyone with a different answer? Okay, let's do it together. We have a product of two functions, right? Okay, I'll let u at x to be e to the power x and v at x to be ln x squared. Okay. U at x is straightforward. The derivative of this function will be this function, right? But check v at x. We have ln x squared, right? We have the outer function and the inner function. Okay, this one is not ln x. We differentiate these two different, because here you just say it's 1 over x, right? And then here we have ln x squared. We have the inner function and the outer function. Okay. And that means here, which rule are we supposed to use?
The chain rule.
The chain rule. Okay, the chain rule says the derivative of the outer function times the derivative of the inner function. Right? Okay. I will write this as in okay, let me introduce another variable. W equals x squared, right? This means u is equal to ln w, right? Okay, this means v is equal to ln w. Okay, if we use the thing here, the chain rule, v prime at x will be the derivative of this function. Okay, will be v prime times the derivative of w prime, right? V prime, the derivative of v prime is 1 over w, right? Times the derivative of w. W is x squared. The derivative of x squared is 2x, right? But we said our w is equal to x squared. So we need to substitute x squared back here. And if we do that, we'll have 2x over x squared, right? And okay, we have 2x over x squared. This x can cancel out with one of the x's here. And if we do this, you can, we'll have 2 over x, right? This is our v prime. Remember, we said the derivative of this function. Okay, we have f at x is equal to e to the power x ln x squared. We let this to be u, we let this to be v. F prime at x will be u prime v plus u v prime. Our u is e to the power x. We said the derivative of e to the power x is e to the power x. And our v is ln x. So we have e to the power x ln x squared, right? Plus our u is e to the power x, right? Times our v prime. Our v prime is 2 over x times 2 over x, right? We will take out the common factor here, which is e to the power x. If we do that, we'll be left with ln x squared plus 2 over x. This is our first derivative. Do we all agree?
Sorry, ma'am. How did you get 2 over x?
2 over x. Okay. I said, okay, let's say if f at x is equal to, I'm gonna write this as ln 2x. Okay, I'll do another one, g at x is equal to ln 2x cubed. Another one, h at x is equal to ln, let me just say x squared. Okay, suppose we are given these 3 functions, right? And we are asked to find derivative of all of them. Okay, you see, if we look at this function, okay, let me write the other one. P at x is equal to ln x. You see, the only function that is different here is p at x, because this function has ln x. It says a function as x, the inner function is just x, right? Okay, let me just do them the same. Let me just say these 4 functions, they are all the same. They have the inner function and the outer function. The inner function, outer function, inner function, outer function, inner function, outer function, right? Okay. If we are differentiating a function which has an inner function and the outer function, the derivative of the function will be the derivative of the outer function times the derivative of the inner function. Okay, let's take get x equals ln x, right? Okay, I'll write the inner function, I'll let the inner function to be u. So we have u equals x, right? And I will write the outer function as v. This means we have v equals ln of u, right? Okay, if this is the case, p prime at x will equal to the derivative of the inner function times the derivative of the inner function, right? What do we get if we differentiate ln u? We get 1 over u, right? we get 1 over u. What do we get if we differentiate x? We get 1, right? So it's times 1. So this means we have 1 over u. But we know that our u is x. So we need to substitute back x. So this means p prime is equal to 1 over x, right? Okay, let's do another one. We said another one is ln 2x. Okay, now let's say we have our f at x equals ln 2x, right? We said we'll let the inner function to be u. So we have u equals 2x, and we have v equals ln v, ln u, because you said this is u, right? So we have ln u, and our f prime at x would be v prime, the derivative of the outer function, times u prime, the derivative of the inner function. If you differentiate ln u, you get 1 over u, right? Times, if you differentiate 2x, you get 2, right? And this means you have 2 over u, but we said u is equal to 2x. So this means if we substitute back u, we have 2 over 2x, which is 1 over x, right? Okay, let's do another one. We said another one, g at x equals 2x cubed. Okay, g at x equals ln 2x cubed, right? Here, the inner function is 2x cubed, meaning we let our u to be 2x cubed, right? And our outer function, which is v will be ln u. If this is the case, using the chain rule, g prime at x would be the derivative of v times the derivative of u, right? The derivative of v is 1 over u, right? So we have 1 over u times the derivative of 2x cubed. The derivative of okay, sorry, I had to mute myself. There was like so much noise outside. Okay, we said the derivative of u. Okay, u is 2x cubed. The derivative of 2x cubed is 6x squared, right? So this means we have 1 over mu times 6x squared, right? But we know that u is 2x cubed. So this means we have 6x squared over 2x cubed, right? The next step is to simplify. We have 2 over, we have 6 over 3, that give us 6 over 2, that give us 3. We have x squared over x cubed, that give us x. So this means the derivative of ln 2x cubed is equal to 3 over 2, right? Okay, let's go back to our derivative. We said f at x is equal to ln x squared, right? Was it ln x squared? I think. Okay, here we have u equals x squared, and we have v equals ln u, right? Okay, using the chain rule here, the chain rule will be f prime at x equals v prime times u prime, right? Okay, we said the derivative of ln u is 1 over u, 1 over u times the derivative of u prime. U prime, u is equal to x squared. The derivative of x squared is 2x, right? So this means we have 2x over u, but we know that u is equal to x squared, right? So this means we have 2x over x squared. This x will cancel out with one of the x's here, and we will have 2 over x, with the left with 2 over x. Do we still have questions? Yes, no. If your hand is up, please unmute your mic and I guess we don't have questions. We move on. Supposed to start optimization, but I only have 7 minutes.
Mr. Ngoma, can we get the answer for the second derivative?
But that's where it differentiates the first derivative. What did you get as your answer?
I think now we're at the first derivative, and then the original answer said we need to work it to the second derivative.
Hey, you have to do the product rule again. The x ln x squared plus 2 over x. I don't know the answer, but let's work it all together. Another thing, if we said, what is f prime?
Nx squared plus 2 over x.
Thank you. Okay. We have again the products of two functions, right? Okay. Let our u at x to be ex. Let our v at x to be ln x squared plus 2 over x, right? Okay, we need to find u prime, v prime. U prime, it's simple because we just do what? It comes back as it is. Okay. Then v prime, in v prime we have two functions, okay? We can say we differentiate ln x squared with respect to x plus the derivative of 2 over x with respect to x, right? We do the derivative of ln x. We did the derivative of ln x. Wait, derivative of ln x squared. Ln x squared. We said the derivative of ln x is 2 over x, right? So we have 2 over x plus the derivative of 2 over x. Remember, we can write 2 over x as in 2x to the power minus 1, right? Then you can use a power rule. Yeah, if you use a power rule, you should get minus 2 over x squared. Right, okay. Then the next step is to substitute them back to your product rule. So we have f prime prime equals u prime v plus u v prime. Our u prime is ex. Our v is ln x squared plus 2 over x plus our u is ex. Our v prime is 2 over x. Okay, this is minus 2 over x squared. And this gives you ex, taking out ex as a common factor, ex into ln x squared plus 2 over x plus 2 over x minus 2 over x squared. Okay, we have 2 over x and 2 over x, right? We can add these two to get 4 over x. So we have ln x squared plus 4 over x minus 2 over x squared. Do we have questions? Yes, no. Did you all get this answer as our second derivative?
That's the answer I got.
Thank you.
Yes, that's correct.
Okay, let me give you one more example. I can't start something new now since I only have 2 minutes. Okay, guys, please let's work on this. We have 5 minutes again to work on this. I know we only have 1 minute. Can we do it like, can we stay for 10 minutes? No, to do this example. Yeah, here we are given this function. We are asked to find f prime and f prime prime. We have 5 minutes to work on this one. Okay, it's 12:30. We'll do it together at 5 to 25 to 8. Yeah, in 5 minutes. Guys, what did you get, like, on your first derivative?
E to the power of
E
3 to the power
2x,
2x
open bracket,
in bracket
2nx to the power of 3,
then x cubed.
yes, plus 3 over x.
Plus 3 over x.
Close bracket.
Did we all get this answer? Right.
Yes.
I got it.
All right, thank you. What did you get as your second derivative?
I believe I got that one wrong.
What went wrong? Let's work on it. We have u as e to the power 2x. We have b as ln x cubed, right? We need u prime and v prime. Okay, yeah. If you check u has an inner function and the outer function, right? Okay, I'll let the inner function to be w. So we have w equals 2x, right? And then this means we have the outer function. Okay, I'll name the outer function. I'll let the outer function to be z, right? We have z equals e to the power w, right? Okay, this means, yes?
Sorry, before you continue, I'm just not sure. Can I just try give you an answer that I got, which was for the second derivative, which was e to the power 2x ln x cubed plus 3 over x into 3 to the power e to x, or 3e to the power 2x.
The first derivative. So I have to work on the first derivative with everyone. Then once we are done with the first derivative, then we move to the second derivative.
Okay, ma'am.
Okay, we have u equals to e to the power 2x, and we said we have two functions here, an inner function and the outer function. We let the inner function to be 2x, we let the outer function to be z, which is e to the power w. And the chain rule says the derivative of the composite function will be the derivative of the outer function. The outer function is z times the derivative of the inner function. The inner function is w. So we have z prime times w prime. The derivative of z prime of e to the power w is e to the power w. So we have e to the power w. The derivative of w is 2x, right? The derivative of 2x is 2, right? And we know that w is 2x. So this means u prime is 2 e to the power 2x, right? Okay, we have v is equal to ln x cubed. Again, here we have the inner function and the outer function. I'll let the inner function to be w1. w1 is x cubed, right? And I'll let the outer function to be z1. z1 is ln w1, right? Okay. We will use again the chain rule. This means v, the derivative of v will be z1 prime times w1 prime. We know that okay, we know that z1 is ln w. The derivative of ln w is 1 over w, right? And we know that W1 is x cubed. The derivative of x cubed is 3x squared. And we know that W is equal to x cubed, right? So this is 3x squared over x cubed. And if you simplify this, you should get 3 over x, right? Then we go back here. Yeah, we go back here. We had u and v, okay? F prime would be u prime v plus u v prime, right? U prime, we said u prime is 2e to the power 2x. And we said v is ln x cubed. So times ln x cubed plus v is e to the power 2x, and v prime is 3 over x, 3 over x. And we can take out the common factor here, which is e to the power 2x. If we take out e to the power 2x here, you'll be left with 2 ln x cubed, right? Again, if you take out e to the power 2x here, you'll be left with 3 over x. Is it fine now?
Yes.
You sure?
Yes.
Yes.
This is the first derivative. You said, what did you get as your second derivative? Okay, let's do the second derivative together. The second derivative, you'll get the second derivative by differentiating the first derivative with respect to x, right? Meaning, we have d over dx of e to the power 2x times 2 ln x cubed, right? Plus 3 over x. Okay, we have two functions, one,
Miss Nkomo,
2.
could you
Yes.
please explain the 2 ln x cubed for me, please?
This 2 ln x cubed.
Yes.
I took it from here as it is, which
Yes,
is.
I want to understand that part because I didn't get it when you finished off that part.
Oh, okay. We had 2ex, 2 e to the power 2x times ln x cubed. And I took out this. If I took out this from here, I'll be left with 2 ln x cubed. Right?
Okay.
That's how we find 2 ln x cubed. Is that fine?
I'm not sure, but I'll watch again and I'll catch up, I think.
Okay. You say so. Okay, I'll let our u to be ex, e to the power 2x, and our v should be 2 ln x cubed plus 3 over x. Okay, we need u prime and v prime. We said the derivative of e to the power 2x is 2 e to the power 2x, right? Okay. We have v as 2 ln x cubed plus 3 over x. Okay, we can write v prime as in 2, the derivative of ln x cubed with respect to x, plus 3, the derivative of x to the power minus 1. because it's 1 over x, right? We have 2 times, what is the derivative of ln x cubed? We said it's 3 over x, right? It's here.
Correct.
Is 3 over x. So we have 2 times 3 over x plus, what is the derivative of minus x to the power minus 1? That's okay. Let me write
3
this
over
down.
x to the power of 2.
Minus 1 over x squared, right?
Yes.
And this is the same thing as x, 6 over x minus 3 over x squared. This is our v prime. Okay. We have f prime prime as in u prime v plus u v prime. Our u is e to the power 2x. And the derivative there is 2 e to the power 2x times v. We said v is 2 ln x cubed. 2 ln x cubed plus 3 over x, right? And then we have our u, so it's plus e to the power 2x. And the derivative of v prime, we said it's 6 over x minus 3 over x squared. Okay, this is minus. Then you can simplify further. You can take out e to the power 2x as a common factor. If you do that, we should get e to the power 2x. Okay. If I take out e to the power 2x here, I'll be left with 2 times this bracket, right? I can multiply. Okay, let me write this as in 2 times 2 ln x squared plus 3 over x. I take out e to the power x there. I'll be left with plus that bracket, which is 6 over x minus 3 over x squared. Right? I think we can still simplify better. And you'll have e to the power 2x, okay, times this and 2 times this. This will give you 4 ln x squared plus 6 over x, right? It's 2 times this, it's this. 2 that times this is this. Plus times this, it's 6 over x, right? Plus times minus this, it's minus 3 over x squared. So we have 6 over x, and 6 over x. We add them, and if we add them, we should get 12 over x minus 3 over x squared. Yeah. Did we all get this answer?
This other one.
I omitted the 2, so I got 9 over x, but I see what was the mistake that I made there instead of the 12 over x.
Oh, all right. Thank you.
Yeah.
Okay,
Yeah, I got the
in
same,
your
I got
spare
the same
time,
answer.
please try this one. E to the power 2x over ln x cubed. Right, that's number 1. And number 2, this is 1. Number 2, f and x equals e to the power x over 2x plus 1. Okay, you need to find f prime, and the third derivative. Okay. In your spare time, before our next class, because next class I will start. Okay, today we are supposed to do the optimization of a function with one variable, but we couldn't because of time. So next time I will continue there, but please work on this too. Yeah. I think we should end here. We can end here if we don't have any more questions. Okay, let me stop recording.